Now that we have our Python package, what's next? Well, to get it ready for mass consumption, you want to make sure that you rigorously test your code. So unit testing your code is one way of telling other people, other users, other collaborators that you're respectful of the time and that you've done the absolute minimum to make sure your code performs as expected. We have TQ. This is the Python package that we developed over the last few episodes of the series. And then we have TQ-V. It adds additional information onto our output. But how do you know that your code would always perform as expected, even under conditions that you may not have considered before? So unit testing is one way to achieve that. It gives you a peace of mind, it gives your customers some assurance, and at the very least, it shows others that you care. And it's not just about benefits to other people. Performing automated tasks like this, writing unit tests, they add clarity to yourself as the developer as well. And it will save you a lot of time in the long run. So if you follow a true and tested testing methodology, it helps you isolate bugs, which means less troubleshooting, more modular, more compartmentalized code base, and a shorter iteration cycle. So there are many testing frameworks in Python, but we will be doing our tests using unit tests. And unit tests, you may have guessed it, ships with Python as well. So unit tests is a built-in testing framework for testing of Python code and provides just the right tools for you to construct and run your tests. Other popular third-party testing frameworks such as PyTest builds on top of this unit test framework. So before we get into it, make sure you subscribe so you get notified whenever there's a new episode on this channel. I teach about Python, JavaScript, Solidity, blockchain programming, computer vision, automation, a ton of other programming related topics. So now let's get started. So open up Visual Studio Code or open up your favorite IDE. Make sure that you're still in the right directory. There's TaskQuant in here, so we're in the main directory, just to show you where I'm at. So I'm currently in the main directory. I'm gonna clear the screen out. And within it, there's the test. And test folder is something that we created in the last episode, but we really haven't done anything in it, so it's completely empty. So the first thing we want to do is to just maybe create a new init, dunder init.py, turn this into a module, and then from it, we can go ahead and now create our first file called taskaccum.py. And taskaccum.py is named after the file that we want here. So this is one way of doing it. Another way of doing it is to just create a folder, and then within this folder, create a folder for score and create a folder for utils, and put all the tasks related to score into the score folder, and then put all the tasks related to utils in the corresponding utils folder. So then in your task, you would have score and you have utils, and both of them would also be a submodule. That's also another way of doing it. I just took a look at the code and it doesn't look like we need to do that. It's not overly complex at this stage, so we're probably just gonna stick to taskaccum.py, just a simple file instead of having to have a submodule in it. And then the next thing I want to do is that because this is unit testing checks a small component in your application. It checks for this one small unit of code, this one small unit of feature, and it tests for that, and it says whether or not that thing works or not. So it helps you isolate what is broken in your app, and it helps you fix it. It helps to troubleshoot and narrow down to that one small unit of functionality. So to perform good unit tests, your code needs to be modularized in the first place. You don't want to have a massive function doing a ton of things and then trying to write a unit test just to test of that function. That kind of defeats the purpose of that. And compare that to integration tests. Integration tests checks that all the components in your application, they play nicely with each other, they operate with each other, all right? And unit test is just looking at one small thing at a time and trying to see, okay, can I isolate a problem? If there is something breaking in the application, can I isolate that to what unit is of work is responsible for that bug? So that means we need to make some changes to our initial code base. So if we look at TaskQuant and you look at the main.py, init.py, and there is the score, right now in the accum.py, you see all of the logic being grouped in this one massive function called scoreboard. And scoreboard takes a task path and then it goes ahead and proceeds to execute all of this to the very end, and then prints out the table. And this is obviously not very modular, because when you want a task and you put in, if you fit in an input to scoreboard, this is what you get in the output. If something breaks here, we want to isolate and say, okay, where exactly is it breaking? Why is it breaking? Well, is it the group by? Is it the aggregation? Is it? And doing it this way is just not going to be modularized enough for us to be able to write good tests. So today's task is twofold. First is to refactor accum.py, make sure they're modularized, make sure all of these are in small components, small functions, individual functions, doing one thing only and doing that one thing really, really well, not trying to do 10,000 things at the same time. And then once we have that, we're gonna go and write our test file. Okay, so let's go ahead now and just take a look at the top score accum. So score accum, this is what we have. We read in the task, and then we say completed, total completed, and then we say, okay, well, if the total completed is less than 1, then we want to put out a simple warning. So that's something we can test for, and that's something we can isolate as well. So how do we start from here? So the first thing you want to do is to make sure that you have a action plan. And so this is what it's supposed to do, right? Now, first of all, it needs to, let's put up some doc strings in here. So I'm gonna just hide the sidebar. And the first thing we're gonna do is we're gonna say, it needs to extract the task from TaskWarrior. So that is the first thing it needs to be doing. And then the next thing it needs to do once it's done that is that you go and perform the analysis. Perform transformation. Okay, we may still break this perform transformation down into even smaller components, but for now that is good enough. So let's go ahead and just create the extract task at the top. So extract task is probably just gonna be something like this. We're just gonna copy that, go all the way at the top, and we just have to create the function, and we say define extract task, and we are just going to do this. There is a task path, so let's add that in, copy this, paste this in, and we're just gonna return completed. In fact, you may just simplify this and just return this directly. So just like that, remove this, and that would be extract task. Now we don't have the line up here anymore. So what we need to do is to just go ahead and just say extract task, and we have to pass in a task path because that is what is required. So let's copy this and paste this right in here, and that is gonna be our completed task. Everything else still works the same. Really what we did was we just take away that small component, put them into its own unit function. So there is this function that says extract task, and then when we write our test, we can just test and see whether or not this always perform as expected. All right. And what else do we need to do next? We look at this. It says, okay, if total completed is less than 1, okay, that's fine. This is all fine. We don't need to change anything. But what we can do now is to basically take the second part of this, the task incompleted, and move them out as well. And if you look at the output of this, it's all the way down to line 56. So this from here, from 38 to 56, all of this can be standalone, its own function as well, and just very simple, just do what it's need to do. So it takes completed and it perform all of this down to the dictionary conversion, right? So let's go ahead, copy out all of this, and we can even just move them all the way up like this. And we just have to add a name for the function. We just have to say this, define, and we're just gonna say task to dig. Okay. If you're wondering why I'm putting underscore, it's just to remind other people that is looking at this code, and to remind myself that these are all internal functions. So these are all sort of like private functions that's not supposed to be public facing. Nobody should be calling it from a consumer point of view. It's just really for us as developers to just call it, and we can use it internally for our functions and stuff. It's just a convention really. And here it says CL to append, but there's really nothing to append to. So we want to create CL, and we want to create a list in here so it has something to append to. And if we go down to the CL.list equals to list, we can change that. You can also just keep to it. And now we have defined underscore task to dig. So within task to dig, we go all the way down to act date dig. But what is it that we want to do with this? We want to return something. If not, there is no point just moving them out. And we see that quickly. You see that some of this code is already causing an error. Say act date is complaining that this doesn't exist. It's complaining this doesn't exist. So where is act date? Where is act date dig? So act date and act date dig are all in this function itself. So we want to at least return them, right? So let's see what's missing. There is the act date. So we can do it one of two ways. We can either move this into the function, or we can just export that out. We can just return that from the function. So I guess just to keep things more modular, just these two should actually belong to this as well. So we're just gonna go ahead and move this in here as well. So in that case, we don't have to export act date. It should really belong in within this function. And then what we need to do is to just return the 3 values in here. All right. So let's go ahead and just return the 3 values. We do that. We say start date next, and we do the last one, which is end date. And once we have this, now we have task to dig, and we're really not calling it yet. We only just defined the function itself. So what do we do with it? Now let's copy that and go to where it used to be, And now, what do you return? You return 3 different values. So let's just copy the 3 different values, and let's just say, take this, pass this in. What is that one thing it takes? Let's go back up, let's see. Completed. So it asks for completed, let's pass completed in there. So let's just take completed, pass it in here, like this. And now, nothing should be complaining. You should see that act date dig is done, start date is there, end date is there. And you can even choose to only run the following here in an else condition. So you want to say if this, else this. So this is especially useful if, let's say, task to dig is actually a pretty expensive or computationally intensive operation. It does a lot of work. Let's say it does a lot of kind of group by aggregation, and then it does a lot of parallel operations and stuff. Well, in that case, you don't want to run it if the total complete is not even 0, it's not even greater than 1, because it's just going to be a waste of all the time doing that. So you can even just try to do this and move all of this into the under the else block. We may choose to do that later, but right now I feel like this is kind of good enough. We don't really need to make any more changes, but if you want to, feel free to do that. You should have just tap all of this in like this. It should make no material impact. All right, so what do we want next? We see that we have full date, we have rolling date. And then there is a condition that says that while the start date is lower than end date, do all this. Now this looks like it's another kind of case where we need to just have this on its own. All right, so let's take a look at this. It has start date, it has end date. It says if these 2 conditions are there, then just continue to run this. So I feel like we could move this out like this, and now we can just have this as its own isolated function. And this could be called create full date. All right, so let's go ahead now and let's move this up here. And let's just call it define, and we say create full date. And create full date needs to take a couple of things, because here it's complaining. It says I can't do that because I don't have end date, I don't have this. So what do we need to do? Well, we need to pass those values in there. Yes, so we need to pass in at least start date, end date, and the act date dig. So let's do that. Copy start date, put this in here. Let's put a comma, and take end date, put this in here, put a comma, and then take this, put this in here, put a comma. And now it's not complaining anymore, but now we need to call this function. So let's copy just the right part, come to the right section of your code, look for this section, and we want to pass this in there. So we have the act date dig, and then we have the start date, we have the end date, and we're just gonna call this. And make sure that it's still returning value, because if it's not returning value, then this is it's doing all of this without actually giving you any output. You can't really use them, right? So you want to at least return something. In this case here, the whole point of creating full date is to return a full date. So let's go ahead and return full date. Just to remind you what it's doing, it's saying that if the start date, let's say the start date turns out to be 12th of January, and let's say the end date is 19th of January, it says that first of all, take a look and see whether you can find the value of 12th January. If you can, take the value. If you can't, just replace it with a 0. This is kind of saying the default is 0. All right, and then move to the next one. So move to the next one. So when we have something like, let's say we have 13 January, we have 14 January, 14, 15, but then we have let's say missing dates. So we go directly from 15 to 18 with no 16 January and no 17 January. Maybe because that 2 days turned out to be a weekend and we decided to take a break. We're not doing any kind of work. We don't have any kind of score. Now create full date is actually going to just say that, okay, well in that case, just replace it with a 0. So it's going to go ahead and pad the value and just add 16 January and add 0 for us, right? And it knows how to do that because we just increase the time delta by days equals to 1. So it goes from 12, all it needs is 12 and 19, and it makes sure that every increment of 1 day, there is a value. If there is no value because we didn't do any work, because we were feeling lazy that day, well, it's just going to replace that with a 0. So then it's going to do the same thing for 17 January, and that's what it's doing. So create full date basically makes sure that we have a unbroken series, a sequence of time series that is uninterrupted. Even if the day we decided to take a leave, it would just show 0. It wouldn't just hop into 2 days ahead, right? So with create full date done, we need to make sure we return the full date, and now we can take full date and assign that back to full date. So this is the return value, assign that back to full date. Sounds simple enough? We're gonna do the same thing for rolling date. Rolling date is the same idea. If you look at this chunk here, this is an area where we could just completely isolate as well. So let's bring that all the way up. And let's call it, what do we call it? We say create full date. then what we need to do now is to have a rolling accumulation, right? So let's go ahead and say fill the rolling accumulation. We can say fill rolling date if you want to. If you find a better name for it, feel free to use it, but I'm just gonna add a comment here just to remind me what I'm doing. Maybe add a docstring in here as well. And this is what is it doing here? It's saying that this is just creating an unbroken series of date given a start and end date. So if I say 12 and 19, then make sure that there is an unbroken series of date. If there is no activities in there, don't break it. Instead, put a 0, pad with 0, and then move on. Okay. And what about field rolling dates? What is it doing? So what field rolling date is doing is trying to create a rolling accumulation, a rolling sum. So perform a rolling sum using data from foo date. So okay, so it's just a simple rolling sum of the foo date. So adding docstring is kind of a good practice as well, and I recommend that you do that. Just I'm doing kind of like an afterthought right now, but really if you have time, you should do it for all of your function just to remind yourself what you're doing, because 6 months from now, 12 months from now, you're going to be coming back to this code and you're going to be looking at that and you're wondering, what am I doing in this? You know, why am I creating this? So just do yourself a favor, do it. I'm trying to make sure that the video doesn't get overly long, so I'm trying to take some corners here, take some shortcuts here, but make sure if you have time, pause and actually write the doc strings and the comments to help yourself out. Just do it for yourself. And I'm just gonna have to return something, because if I don't return something, then what is the point of doing this function, right? So let me return rolling date. So I can now take this and pass that into field rolling date, and I can say this is just my rolling date. And I would just have my foo date in here, just like what I've done before. So you have the foo date, you have the rolling date. Now let's take a look at what we have now. And actually this is a good time to change our comments here. We don't actually have perform computation now. Let's take a look. We have extract task, which is done, which is performed here. And then we have the create foo date. So we're gonna say create foo date. No unbroken task. No unbroken. Maybe we just say pad missing days with 0. That's probably more descriptive of what it's doing. And what we do next is we do a rolling sum. Okay, so create. Instead, I think we call it fill rolling date. So what next is kind of just combine the result from foo date and rolling date. So foo date belongs to, kind of think of it as a list, rolling date is a list. We want to combine them so that we have this result side by side. Kind of in a tabular format, it will look like one column and another column, all right? So how do we do this? Well, we can say maybe isolate out the create, maybe isolate out this component, or maybe even up to this area. So depending on how you want to structure here. But for me, I feel like I want to still put the headers within the main function itself. So I really would just maybe move this out. Okay, so let me just go ahead and do that. And I'm going to call it create combine table. So define create combine table. If you don't want to put the underscore before all of the function names, if you don't have to. That's up to you, what you want to do with it. I just choose to put an underscore for any functions where I'm not expecting this to be an interface to the end user, to the client itself, where it's supposed to only be used internally. So create combined table, it takes a few things, because here you can see there is the foo date and then there's the rolling date. So at the minimum, it needs the 2 items to work. So let's put foo date, let's put rolling date. And let's copy just the right part. And we move this down just like this. So there is the create combine table. So you want to give it a name, and we name it combine L, I believe, because now it's missing, and it's missing because we didn't create that yet. So let's do that just like this. And then we have the combine L headers, and then we have the list. If you want to keep it this way, you can. If you want to just simplify it, you can just take this component out and copy that, paste it in here. Now you don't need that anymore. If you still want to keep this to remind yourself, you can. Just have to add that somewhere, maybe this, and you want to tap it in, just kind of as a reminder what you're doing with this, because it looks very fancy, but really what it's doing is that you're using ANSI to just change the style of the font a little bit on the terminal. So you have the combine L and you have the combine L headers, perfect. And now it's time to decide what to print it with. Do you want to print it with tabulate, or do you want to print it with a create table? This is kind of its own thing, right? So we can just go ahead now and just take all of this out. And we're gonna move that all out into its own function. And within this function, we're just gonna say create table. But create table has already been used, I believe, because we did import the create table. So you don't want to give it the same name. You want to give it a different name. And I'm just gonna say define create table auto. So I'm gonna say automatically decide what to do with it. Okay, if the user has tabulate installed in its environment, then use tabulate to print it because it's prettier to look at. But if he doesn't have that, well, just use our create table function. So it looks like there's a few things here that's complaining. Let's put them into the parameters. Combine L, let's put a comma. Combine L headers, let's take that and put that into second one as well. So that's the second argument. Verbosity is also one of them. Let's take that and print that in here. And what else does it need? It needs a total completed and aggregation date. So let's do the same thing. Just copy that and put it in here. And finally, aggregation date, and put it in here. And now we have the create table auto. So let's take exactly the right part and whoops, copy this. And we're gonna have to go all the way to the right section of our code. I believe it's this area. Did we miss our bracket? So this is how we do create table auto. Now we have combine L, which is from here, combine L headers, which is from here, verbosity, which is from all the way up top. This, so it's just gonna pass, if it's false, it's just gonna pass it to false. Total completed is just total completed from the very top as well. Total completed is here, the length of completed. And then we have act date. And act date, we don't have that yet because we moved that out into another function. Remember, we moved that out into this function. So what we can do is that act date dict is returned, and maybe we can use the length of this dictionary. Okay, just to show you what it means, if I open up Python and I create a simple dictionary, so let me say D equals dictionary, and I have A and I have B. If I say the length of D, it gave me 2. So you don't have to do something, you don't have to try and take the dict and take the keys and take this and then you take the list of that. I see some people who likes to do that, just say list and then you take that and then you put length. It's not necessary. This is a lot of code to just accomplish the same thing as length of D. So what I can do is I can just take the length of this act date dict, right? So let me just go all the way down here, and instead of act date, I'm just gonna say length of act date dict. And that would just do it for us, I believe. So this is a whole function. If we want to, we can return something. We can, for example, return all the tasks and save that. And there we have it, our newly formatted accum.py. Just to make sure that everything still works as expected before we start writing our tasks is we just need to quit this out. And let's go ahead and just call Python, run this as a module, TaskQuant, give it a path. And without the verbose mode, let's run it and let's see if everything still works. So apparently we missed out something. So where is that something? Let's find out. So it looks like we haven't really returned the combine L here. So what we need to do is to just return combine L, and we just need to make sure that create combine table actually return that. So it actually returned this. Now we save this, run it. Okay, so this is without verbose mode. Let's bring it up. This is without the verbose mode. What about with the verbose mode? Let's put the -v. Okay, now it's saying that this has no length. And it tells us that in line 92, there's something in here that we break. So let's bring this down a little bit and let's see what we miss out here. Well, it looks like it's trying to print length when that doesn't exist. And total completed as well. So what needs to happen here is we either try to, instead of total completed, we just have to pass a length, a fixed number, just a number, and we say length. And what we need to do here as well is just the length of date. So we just say date length. And now this two needs to be change up here as well. So we just have to have, instead of act date, we have date length. And then here we have completed length. And if we go all the way back down, this is total completed. So that's not correct anymore. So that's not correct anymore because we need to pass this as a length. So let's see. And it is. So yeah, this would work the same. This will also work, right? This is either of this. But since I already done that, I don't need to perform the computation again. Just pass total completed. So this will work. This will also work. But I'm just gonna stick to total completed because I don't want to redo the computation. So every time you do something like this, it needs to recompute the length of that. Not very efficient. So just keep, you already have that. So that is fine. Now let's save this. Let's go back in here. Let's print that. Okay, now it's working. We see that the verbose mode is working. Without verbose mode, it's still working. So cool, all of that is done. If we deactivate our environment and we try to run it from Python, from vanilla Python without tabulate, let's see what happens. Okay, so it's still printing out, that's cool. Let's do a -v, and it still works, all right. So now that we have all of this set up, we are ready to go into our next phase of this tutorial, which is actually writing tests. Take a deep breath, get some water, and when you're ready, let's begin by writing some tests.